Hello everyone, good morning and good afternoon. Welcome to the first Adams Global Webinar in 2014, and my name is Yijun.fan and I'm the Product Marketing Manager for Adams and EV5. So today, the title for today's webinar will be the Functional Mockup Interface for Extended Co-Simulation Support. Today's presenter will be Wulong Song. Wulong is the Adams Technical Support Engineer, and he was the Adams FMI Functionality Developer. So Wulong has a lot of experience with the Adams car-related products and also with the new FMI functionality. So at the end of today's presentation, there will be a Q&A session. If you have any question regarding the presentation itself, or the Adams product or the FMI related functionality, please type your questions down in the Q&A window. We will have them answered at the end of today's webinar. Okay, now I'm going to pass the presenter to Wulong.
Thanks, Yijun. Good morning, good afternoon, good evening, based on where you are in the globe right now. And again, my name is Wulong Fan, and I will be giving you the presentation today. And first, let's start with the list of table of content we will be covering today. And first, we will start with the FMI overview, and then how it's implemented in Adams. I'll show you a few examples, followed by a live demonstration. And finally, we'll talk about roadmap of FMI development in MSC. And finally, we'll have the Q&A session. So let's start with the overview of FMI. FMI stands for Functional Mockup Interface. It is an open standard, tool-independent standard. So you can find its specification here at this website, fmistandard.org. It's intended to improve software model or hardware-in-the-loop simulation of models from different vendors. The FMI project was first initiated by Daimler AG, and it was part of the ITEA2 Modellisar project. The first release, FMI 1.0, was released in 2010, and the development continues through the participation of 16 companies and research institutes today, and you can find the list on its website. And here are some possible applications we have in mind with these FMI functionality. First, for example, your company has two departments working on different things, using different software. Let's say one is working on the gearbox design using Adams View, and the other group is working on the chassis design using Adams Car. And your Adams View group wants to see what the actual load of the gearbox under certain driving conditions, so they can ask for the model in their chassis group and export it as FMU and bring in their own model to do a co-simulation so they can see the actual load of the gearbox. And vice versa, if the chassis group wants to see how the vehicle performance with a very detailed gearbox model, they can ask for the gearbox model exported as an FMU from their gearbox group. And another scenario is that if you're an OEM and you have different components of your vehicle model provided by the supplier in different softwares, and if all software supports FMU, you could easily bring in all the components into your full vehicle model and perform a co-simulation or just a simulation, and to see how the vehicle behaves with all the components modeled. And as I mentioned earlier, the functional mockup unit is actually the instance, the implementation of FMI. The FMU is just a zip formatted file, and it contains a model description file, which is XML formatted, and a dynamic link library with or without the source code of the actual model. And you can also include some additional modeling data files. In the case for Adams, it will be just ACF, ADM, and CMD files. And this data structure provides a very good separation of your model, where you have the description of the interface data, for example, the state variables, the input and output data in one file, and the actual functionality in another file. So the FMI has two modes. One is model exchange, and the other is co-simulation. The model exchange has this import and export architecture where you export your model as a set of equations, and you import that into another tool where there's just only one solver involved in this scenario. Currently, it's limited only to ODE, ordinary differential equations, in 1.0, FMI 1.0, and the differential algebraic equation, which Adams actually uses, will be supported in 2.0. And the co-simulation scenario is different from model exchange, where you use this master and slave architecture, and you export your model as a slave. And along with the model, you have the solver inside that slave FMU, and you bring in that to the master session where there's another solver. And during the co-simulation, the two solvers communicate with each other at certain time interval. So this is two things different from model exchange. One is they have two solvers, and the other is there's a time interval involved. And the motivation for Adams to support FMI is currently Adams only support this co-simulation and model exchange sort of function with EZ5 and Simulink. But by supporting this FMI standard, Adams could perform co-simulation with other software that supports FMI standard as well. For example, Simulation X, AminiSim, and LabVIEW, etc. And here's a list of tools that supports FMI standard. You can find it here at this website. This is just a part of the list, so you can find the whole list. And right now, I'll show you some implementation of FMI in Adams. And this was introduced in Adams 2013.1. And currently, only co-simulation mode, both for slave and master mode, are supported. And for slave mode, you can export your Adams model as an FMU. As I mentioned earlier, the ADM, CMD, or ACF file, and all the model relevant file will be included in that FMU. And during the co-simulation, the other tool will call Adams, and you can specify whether the slave FMU could be visible or not. And the master mode, you can bring in other FMU from different software into Adams. And during the co-simulation, Adams will call the other software, and the two solvers will communicate in a certain time interval. And currently, only FMI 1.0 is supported. And Adams FMU requires an Adams installation as well as Adams license to run. Even if it's a slave FMU, you want to use it with another software. And Adams machinery now provides this new motor module, which also supports FMI, which means you can bring in a model of your motor in FMU format into Adams. And as you can see, the FMI support for Adams will be based on the current controls module, so the interface will be exactly the same with the current controls interface. And here shows the controls plan export, where you generate a slave FMU from Adams. And it's exactly the same with the current controls panel. And what difference is only you have an additional option here as FMU. And here is the control system import, and it's also the same with current control system import panel. And a little bit different is that you have these two extra options. If you specify FMU here as the external system library, you will be asked to specify a communication interval, and also you can specify whether the slave FMU will be visible during the co-simulation. There are other vertical products from Adams where the FMI function is also supported. Here is an example for Mechatronics, which is built upon controls that provide you better signal handling of the control system. And it shows you how to generate a FMU from machinery, Mechatronics, I'm sorry. And here is how you bring in another FMU in Mechatronics. It's the same with current Mechatronics interface. And Adams chassis also supports FMI, and you can bring in FMU from other software into chassis and perform co-simulation. And from now on, I will show you a few examples. The first one is a ECVT, electrical continuous variable transmission example, which you can find in power split hybrid cars. And in this transmission, you have a set of planetary gears, and you have the motor, generator, engine, and vehicle connected to each mode of the planetary gear. And by varying the speed of the motor, generator, and engine, you have this continuous variable speed of your vehicle. And for this example, the transmission is modeled in Adams field using Adams machinery, and is exported as an FMU, and we bring in that into an Adams car session where you have the vehicle model. And during the simulation, the Adams car session will call the Adams field session, and you can actually see the two processes running in parallel and communicate at certain time interval. And here, the result shows as the motor speed varies, the engine speed kept constant, and you can realize this accelerating and regenerative braking of the vehicle. And in the end, there's a short period where the engine, which is connected to the carrier gear, as you can see here, and the engine is shut off, and there's a short period of pure electrical drive of the vehicle. And this is actually the first time that two Adams sessions could co-simulate with each other. And previously, without this FMI interface, it will be very hard or impossible to do. And this will be very beneficial in your company. There are groups using different Adams products. They can now share models easily using this FMI functionality. And here's another example. It's actually put up by our colleagues in Sweden. And it's about an offshore riser platform where you have this riser connected to a platform using a set of hydraulic tensioner. And while the platform flows up and down, maybe it's on a ship, and the hydraulic tensioner will try to keep the vertical force on the riser constant. And in this model, the platform and riser as well as the cable are modeled in Adams machinery, in Adams field. And the hydraulic cylinder are actually modeled using Simulation X, and they import it into Adams by using Simulation X FMUs. And the motion of the platform is controlled using a motion element in Adams field. And the hydraulic cylinder will try to keep the riser force constant. And the riser is elastic, as you can see, it's a discrete beam, and is subject to buoyancy and current loads. Here shows how the model looks like in Simulation X. It's modeled in pairs, so you have 8 FMUs in total, and the 8 FMUs are brought into Adams, and Adams call all 8 Simulation X FMUs during the co-simulation. And here you can see the animation where the platform flows up and down, and the hydraulic tensioner tries to bring the riser to keep the vertical force constant. And now I will show you a live demonstration of a Adams vehicle model modeled in driveline along with the clutch FMUs generated in Simulation X. This clutch FMU is actually provided by ITI, and it's a very detailed clutch model where you have this control valve and cylinder as its support orifices. And I'll show you the model here. Because we are doing a webinar and using this might take a little bit longer than it usually takes. And Adams driveline is just a plug-in for Adams car, where it provides tools to better model the driveline components of your vehicle. For example, in this case, the automatic transmission was modeled using driveline components such as the torque converter and the planetary gears. And this model is already set up the plant input and output to hook up with the simulation clutch model. And now I'll do is to bring in the Simulation X FMU. It's very easy to do. It's basically the same with current controls. So if you familiar with the controls already, won't be a surprise for you. And the communication interval was suggested by our friend in ITI. It's based on the dynamics of your clutch model, actually. And because it's just an open loop, it won't require too high frequency communication. We just specify it as 1 millisecond. And we'll do this twice because we have 2 FMUs in this model for the clutch. As you can see, it's very easy to do, and now we'll just need to simulate the event. This simulation takes about 2 minutes to went through, but since we are doing a webinar, it may take longer. And while it's running, I'll just show you the result here. During the co-simulation, one clutch was released and the other is engaged. I'm sorry.
Okay, so again, if you have any question regarding the presentation itself or regarding the FMI functionality, please type the question in the Q&A window. Please don't type it in the chat window because it's going to be buried into the conversation. And
well, the WebEx mixed up with my presentation. I'll try to bring back that presentation, and the simulation is running.
Okay. Yeah, I can see your presentation.
Yep. Oops, sorry. Now here shows the result. As you can see, the clutch, one clutch was released and the other is engaged. And here the results are shown in comparison with the baseline model where you don't have this detailed clutch model, and the clutch pressure was only modeled using the continuous step function. And you can see the difference here. The detailed clutch model pressure is actually not varied continuously. So you have this sudden change in the torque it conveyed, and you can see it bringing some extra dynamics to the model. And while the gear shifts from second to third, the engine RPM drops. And again, because this is just an open loop simulation, the communication interval was not required to be very high. Oh, okay, now the simulation is already finished. We'll just wait for it to load the animation. And please notice the actual. Thanks. Please notice the actual torque changes during the gear shifting events. There's one. It shows the torque in one clutch, and now it changes to another clutch. I'll play it again. As you notice the torque change in the clutches. And then we went further to include a very detailed engine model to this, to the model we just simulate. And the engine is the previous model has a constant torque for the engine. And for this one, instead of using a constant torque, we bring in an actual engine model. It's also provided by ITI. And the engine torque was modeled using actual combustion equations. So you have this varying engine torque. and the engine is controlled using a controller. And in this case, we're using the constant torque controller. So the controller will vary the throttle of the engine based on the crankshaft speed. And we can see, because the engine is closed loop control and the dynamics of the engine is very fast, so this requires a long time to run. So we'll just show you the result here. As you can see the result, there are some very high frequency vibrations in the longitudinal acceleration that's caused by the engine. And you can see the engine torque varies constantly during the simulation. And here's the slow motion. You can see the engine torque varies across the 4 strokes of the engine cycle. And as you can see the benefit here, you can very easily include a detailed engine model into Adams, where previously it will be very involved to do this. Either you have the analytical function for the engine, or you import a spline of the engine, and it will be even harder to do a closed loop control. But with the FMU, it's just a single click away, so it will be quite easy to do this with the FMI functionality. And here I'll show you what the roadmap is for the FMI development here at MSC. Currently, since we are supporting FMI 1.0, we'll have the plan to support 2.0 in 2014 if it's finally released. As I mentioned earlier, it's currently still release candidate, and we will support that 2.0 when it's officially released. And also the model exchange FMU import functionality will be also supported. And the EZ5 is a product from MSC. It's for the 1D simulation, and we will also support FMU both co-simulation, export, and import for EZ5. And different from Adams, there will be no installation or license required for the co-simulation of FMU. And here is the summary of what we covered today. And first, we have an overview of FMI. FMI is the tool-independent standard for exchanging model and performing co-simulation, and how it's implemented in Adams currently. The FMI 1.0 standard is supported, and for both master and slave mode for co-simulation, and it's based on Adams controls. And we have a few examples, both by Adams and Adams co-simulation and Adams Simulation X co-simulation. And we have a live demo, and you can see it's very easy to use. It's exactly the same with how you use controls right now. And I talked a little bit about communication interval based on the dynamics of your slave FMU. And finally, I showed you the roadmap. And now I'll bring the presentation back to Yijun.
Okay, thank you, Wulong. Again, so as Wulong mentioned before, we just showed an example about the co-simulation between Adams and Simulation X, but the actual application is not restricted to Simulation X. We actually support all the co-simulation between Adams and every software that supports the FMI standard. For example, the LabVIEW and also some other different types of softwares. And also because since basically all the Adams product, we do support the FMI functionality within each product, like Adams View, Adams Car, Adams Driveline, which means you can now start to perform the co-simulation between one Adams and another. And that is something you cannot do without the FMI functionality. So with that, we will go to the Q&A session. So before we